In this video, we will be studying about different types of graphs. Okay, so the first one is complete graph. Okay, and complete graph is represented using the term Kn, where n indicates the degree. N indicates the degree. Okay, so what is the definition of complete graph? A complete graph of n vertices denoted by Kn is a simple graph that contains exactly one edge. Between each pair of distinct vertices. Okay, if I take two vertices v1 and v2, there exists exactly one edge between this v1 v2. So this, since there are two vertices, I call this as graph as K2. What is Kn? Kn indicates if there are n vertices in a graph, then there exists only one edge between those n vertices. Okay, so let's see examples. K3, it means what is K3? I will have three edges. I will have three vertices. Let me call them as v1, v2 and v3. Right, now between any two set of vertices there is exactly one edge. So between v1 v2 one edge, between v1 v3 one edge, and between v2 v3 there is one edge. This kind of graph is called complete graph. And the other important point is the degree is same. Complete graph has same degree. Okay, you see, degree of this is 2, degree of v2 is 2, this is also 2. Right, complete graph. The number of edges in a complete graph with n vertices is n into n minus 1 by 2. Number of edges in a complete graph with n vertices is n into n minus 1 by 2. You can take this example of k equal to 3. If you put here, it is 3 into 2 by 2, that is 3. So there are 3 edges in a complete graph. Okay, let's see this K4. K4 indicates there are 4 vertices v1, v2, v3, v4, and right, there is an edge from v1 to all 3. There is an edge from v1 to v2, v2 to v1 to v3, v1 to v4. Same way from v2 to v1, v2 to v4, v2 to v3. Then from v3 to v1 to v2 and to v3. From v4 to v1 to v2 to v3. Right? So this is called complete graph. If there is exactly one edge between each pair of distinct vertices, then we say that graph is complete graph. You see the examples here. K5 means I am having 5 vertices. There should be one edge from v1 to all other vertices. From v1 to all other vertices, I should have an edge. See, v1 to v2, v1 to v4, v3, v5. Again, now from v2 to v1, v2 to v3, v2 to v4, v2 to v5. Same way from v3, I should have an edge to v1, v2 already exists, then v3 not required, v4 and v5. That's why we are saying simple graph means no self loops and no multiple edges. Okay, so this is about the one type of graph, complete graph, denoted by K and n, where n indicates number of vertices in that graph, and the condition is that all from a vertex v1, if there are 3 other vertices v2, v3, v4, there should be an edge from v1 to v2, v3, v4, and if from v2 there should be edge to v1, v3, v4. That way you should have mapping. There should be edge between all the vertices. If I take any vertex in the graph, there should be a path from this vertex to all the other vertices. That kind of a graph is called complete graph. And the one important axiom or theorem here is that number of edges in a complete graph is with n vertices is n into n minus 1 by 2. Okay. Next, cycle graph. The other type of graph is cycle graph. It is denoted by Cn, where n indicates number of vertices. Cycle graph is indicated with a number Cn, a notation Cn. N indicates number of vertices. What is this graph? What is this kind of a graph? See, cycle graphs are applicable only for n value greater than or equal to 3. Cycle graphs are applicable only for n greater than or equal to 3. That is the condition, because I cannot say v1 and v2. If I have a graph like this with 2 vertices, I cannot say it's a cycle. Okay, what is the definition of cycle graph? If I start from a vertex v1, okay, I should have exactly one path I should have exactly one path, and I should be able to come back to the same path, same vertex. I should be able to come back to the same vertex. See here, see the example of C3. I have V1, V2, V3. See, I am having a cycle here. I am having a cycle here, right? So, the cycle n greater than or equal to 3 consists of n vertices V1 to Vn and edges V1, V2, V2, V3, Vn minus 1, Vn and Vn, V1. So, you are having vertex, if I say some maybe C3 if I say, or C4 if I say, it means from V1 to V2 one edge, from V2 to V3 another edge, from V3 to V4 another edge, from V4 to V1 again another edge, that way. So, V1 V2, V2 V3, V3 V4, V4 V5, V5 to V1 again. If I have only these number of edges, where you are forming an edge between the adjacent vertex V1 to V2, V2 to then V3, V3 to V4, from there again coming back to V1. That kind of graph is called cycle graph, where this number 4 indicates number of vertices in the graph. The third one is wheel graph. The third type of graph is wheel graph WN, where n indicates number of vertices. N indicates number of vertices. Here a little important point is that if you see the wheel graph W3, if you see the wheel graph W3, if you count the number of vertices, it is 4, 1, 2, 3, 4, right? That is one special thing which you have to note it down. In a wheel graph, wheel graph is nothing but cycle graph Cn, in between the cycle graph, place one vertex, okay, from which can be connected to all the other vertices. So, wheel graph is nothing but cycle graph, in between cycle graph put one vertex, one vertex, and see this, what was our cycle C3, this was our cycle graph, right? A, B, C are the 3 vertices. This was my cycle graph C3. In between put one more vertex D and connect this to all the other 3 vertices. This forms our wheel graph. So, in a wheel there is a center point which will rotate, no? There exists a center point. So, that we are trying to add it here. That will not be counted in this n. So, do not be confused, do not simply count this 1, 2, 3, 4, 5 and say this is wheel 5, it is wheel 4 only. There exists one vertex in between that cycle graph which will be connecting to all the 4 edges, okay. So, that is what, when we add an additional vertex to a cycle Cn for n greater than 3 again, because cycle graphs is applicable only for n greater than 3. So, when we add a additional vertex to a cycle Cn and connect this new vertex to each of the n vertices, connect this new vertex with each of those existing vertices, then we say it is a wheel graph. See here W4, you see cycle 4 is this is my cycle 4, put one new vertex here, from this you connect it to all the 4 edges, this forms the wheel graph, okay. So, this is another type of graph, wheel graph. Next, bipartite graphs, okay. So, we have to talk about a word, bipartition, bipartite means 2 partitions, the meaning is 2 partitions. What is this bipartite graph? Given a graph like this, see this example graph here, given a graph like this, if you have a graph like this, okay, if you can partition that graph, if you can partition the vertices of that graph as 2 different sets, okay. So, what is telling in this graph, if you can form 2 sets, S1 set of vertices and S2 another set of vertices, if you can divide this graph, there are how many vertices are there? See, A, B, C, D, E, F, G, there are 7 vertices in this. If I can form a 2 sets of vertices, set 1 and set 2, such that there is at least one vertex from, there is at least one edge from a vertex in set 1 to vertex in set 2. A vertex in set 1 to vertex in set 2. It means if I can form set like this, maybe A, G and F as one set and maybe B, now we can write it like this, B, C, D and E. If I can partite this graph like this, I am partitioning it. See, I am trying to draw a line here. I am trying to separate the vertices. I am trying to form two set of vertices. Set 1 is one set of vertices, set 2 is another set of vertices, such that what is the condition here? There should be at least one edge. There should be at least one edge from any one of these vertices to any one of these vertices. See, from A to B, do I have, from A to B, do I have a vertex? No. Do I have an edge? No. Right? We don't have a vertex, sorry. We don't have a, from A to B, there is no edge. From A to C, yes, there is an edge. From A to C, there is an edge. That's it. If you can partition the vertices, all the vertices of the graph into two parts, part 1 and part 2, such that there exists at least one edge from part 1, from a vertex in part 1 to another vertex in part 2, then we can say that kind of a graph is called bipartite graph. It means we can do the partition of the graph into two separate set of vertices. Okay. Next, but it should be disjoint. The condition is that it should be disjoint. See, I am forming one set ABD as one set, CEFG as another set. I am having two separate sets. There is no common point here. There should be disjoint sets. Okay, that is the condition. Next one is complete bipartite graph. What is this complete bipartite graph? In bipartite graph, I am saying that if a graph is given, find out can you form two set of vertices such that there exists at least one path. Complete bipartite graph means when you have a graph, if you can form two set of vertices such that from this set of vertices, from the first part, okay, there is a path from each vertex of this to all the other vertices. Again, let's see with examples here. See this K23, it is denoted with the term Km, N. Complete bipartite graphs are represented like this, Km and N, Kmn. You see, I have a K23 graph. I can partition this graph like this. Let me give some names, A, B, C, D, E. So, I am able to form two set of vertices. What is set 1? It contains A, B. And what is set 2? It contains C, D, E. I am able to partition that graph or partition that vertices into two different sets, S1, S2, such that, what is complete bipartite graph? Such that from this vertex A, there should be an edge to B, C, D, E. And from this vertex B, there should be an edge to C, D, E. This is complete bipartite graph. It means all the vertices in set 1, should have an edge with all the vertices in set 2. Then we say it is called complete bipartite graph. Okay. See, if and only if one vertex is in the first subset and other vertex in the second subset. Okay. There exists path. See, here you see from this node I am having path to C, D and E. From B node, I am having path to C, D and E. This is complete bipartite graph. What is bipartite graph? If there are two sets S1, S2, there is at least one edge from any one of the vertices of set 1 to any one of the vertices in set 2. That is partite. Complete bipartite means if set 1 contains 2 vertices, set 2 contains 3 vertices, then from these 2 vertices there should be edge to all the other 3. You see example of K33 from A, B, C and 1, 2, 3. Some names I have given for the vertices. From A there is edge to 1, 2, 3. From B there is an edge to 1, 2, 3. From C there is an edge to 1, 2, 3. Okay, that way you should have edges from, then this kind of a graph is called complete bipartite graph. Okay, so these are different types of graphs we have in graph theory. Let's see some simple problems on this concept. Draw K7. What is this Kn? Kn means complete graph. So I am asking you to draw K7. What is K7? What is the meaning of complete graph? If I have n vertices, then from each vertex in that graph, there should be a path to all the other vertices. So K7, how do I draw? I will draw some 7 vertices like this, 3, 4, 5, 6 and 7. Now I have drawn some 7 vertices. You can draw in any style. From this vertex V1, let me give naming, V1, V2, V3, V4, V5, V6 and V7. there should be an edge. If I choose one vertex V1, there should be an edge from V1 to all the other vertices. See, V1 to V2, V2 to V3, V2 to V1 to V4, V1 to V5, V1 to V6, V1 to V7. Same way, V2 to V1 already exist. V2 to V3, V2 to V4, V2 to V5, V2, V6, V2, V7. Then from V3 to V1 already I have, to V2 I already have, to V4, V5, V6 and V7. Then from 4 I should have to 1, I already have it, from 2 I have it, 3 I have it, 4 to 5, 4 to 6, 4 to 7. Then from 5, 6 and 7, from 6, 7. So this is the K7 graph, complete graph with 7 vertices. What is complete graph? From each vertex there should be a path to all the other vertices, direct path. Okay. Next, K18. What is this Km comma n? This is called complete bipartite graph. This is called complete bipartite graph. It means I am able to divide that graph into two separate set of vertices such that from set 1 there is an edge to all the other vertices. So what is K18? I have only one edge this side and I have 8 edges here. I have 8 vertices here, like this. So this is set 1 and this is set 2. From all the vertices of set 1, there should be an edge to all the vertices of set 2. Since I have only one element, like this is the graph. No, I am connecting, I am having a path from vertex set of S1 to all the other vertices. This is K18. Next, what is K44? It means there are 4 vertices like this and there are 4 vertices like this. From vertex V1, I have path to all the other vertices. From vertex V2, I have path to all the other vertices. Same way from V3, I have path to all the other vertices. Same way for V4, V to this and to this. This forms our K44 graph. What is C7? C7 means cycle 7. It is cycle graph. So 1, 2, 3, 4, 5, 6, 7. So just connect V1, V2, V2, V3, V3, V4, V4, V5, V5, V6, V6, V7. Like this they are connected, and V7 to V1 it has to come back. This is cycle 7. And wheel 7 means put one center and you connect this to all the other vertices like this. This forms our wheel graph 7. Okay. So in exam sometimes you will be asked this kind of draw these graphs, or maybe find out number of degree, in degree, out degree, or degree of each node. Some questions can appear. So you should know what are the different types of graphs we have, right? So in this video we have seen different types of graph. Next we will be seeing some problems on graphs.